Hello students and friends. In this video I am going to discuss question number 8 of the specimen paper of 2022, the paper variant 42 and the subject code 9701, that is the Cambridge A levels. So the question number 8 is ibuprofen and paracetamol are pain relief drugs. Ibuprofen and paracetamol both contain the aryl benzene functional group. Name the other functional groups present in each molecule. So let's look at the ibuprofen molecule. We can say that this is the benzene ring, this is the hydrocarbon part. So this is not the functional group. We can see this functional group, which is the COOH, which is the carboxylic acid. In paracetamol we find the phenol group and we find the amide group. So that's the answer. Let's go to the next question. Ibuprofen contains a chiral center and has two enantiomers. State one similarity and one difference in the physical or chemical properties between the two enantiomers. Now if you look carefully, then this particular carbon is a chiral center because it is joined with four different groups: this part third, the COH, and the fourth is the hydrogen, which is not shown. So all the four groups are different. So that's the chiral center. So it has enantiomers. So what is the similarity? The enantiomers have same physical and chemical properties, and the difference is that they differ with respect to the rotation of the plane polarized light. As you know that the enantiomers rotate the plane polarized light either clockwise or anti-clockwise by the same angle. Now what is meant by racemic mixture? Racemic mixture is when you mix equal amounts of the two enantiomers, you get a racemic mixture. Okay, now let's go on to the next question. Paracetamol reacts separately with the two reagents shown in the table. Complete the table 8.1 by drawing the structures of the organic products formed and stating the types of reaction. So I have once again drawn the paracetamol molecule here for your reference, and we have to say what happens by the action of LiAlH4. As you know, LiAlH4 is a reducing agent and it reduces the carbonyl group to the CH2 group. So this is the change that will happen. Nothing will happen to the benzene ring or the OH group, and the type of reaction is reduction. Now what happens with an excess of bromine water? Now you know that when we have studied the reactions of phenol, so this is the reaction due to the phenol, and the substitution of bromine occurs at the 2, 4 and the 6 positions, but because the 4th position is blocked, the substitution will take place at the 2 and the 6 position with respect to the OH group, and that's the answer. No change happens in the rest of the molecule. Okay, so now let's go on to the next question. One of the steps in the manufacture of ibuprofen is shown in figure 8.2. Write an equation to show how AlCl3 generates the electrophile for the conversion of X into Y. So CH3COCl that reacts with AlCl3, and the chlorine is transferred to AlCl3 in the form of Cl minus, whereby AlCl3 becomes AlCl4 minus, and the CH3COCl changes to CH3CO positive, and because it has a positive charge, this is the electrophile, and this is how the electrophile is generated. Draw the mechanism for the conversion of X into Y. Include all the necessary curly arrows and charges. Okay, so this is your electrophile which has been generated in the first step, and this being electron rich, the one electron pair from the benzene ring will be used to form a bond with the CH3CO group having a positive charge. So this is how a covalent bond is formed using the electron pair from the benzene ring, and therefore the benzene ring no longer remain completed because one electron pair has been used up. So it forms an incomplete ring which is unstable and now having a positive charge. Now we have shown one hydrogen separately, even though there is hydrogen on every carbon, but one hydrogen we have shown separately because this takes part in the next step. In the next step, the electron pair from the CH bond goes back into the benzene ring, thereby completing the benzene ring and neutralizing the positive charge. So you get the benzene ring back, and H comes out as H plus, and the COCH3 has now replaced the H plus over here. So this is the mechanism showing the curly arrows and the charges. Okay, so let's go to the next part. So write an equation to show how the AlCl3 is regenerated. So AlCl4 minus reacts with the H plus, and H plus takes out the Cl minus from here, forms HCl, and what remains behind is AlCl3, and that is how AlCl3 is generated. So this was just question number 8 of your specimen paper, which was presented by the Cambridge board in the year 2022. Hope you understood, and if you liked the video, please give it a like, a comment, and share it with your friends. Thanks a lot.